Every major construction project begins with a physical transformation. Loose earth is excavated and replaced with a material that solidifies into a uniform slab. To achieve this result, builders follow an exact 6-step operational sequence to prepare, mix, and pour structural concrete. This list identifies the 4 raw components required for the operation. Each element has a distinct mechanical role. Cement acts as the glue. Sand fills the gaps between stones. Gravel provides the core strength, and water binds the entire system together. Understanding the distinct physics of these 4 ingredients is necessary for engineering stability. When mixed correctly, they create a material that is used for everything from residential driveways to heavy load-bearing columns. Before mixing begins, every component must be measured. This methodical process is called batching. Structural integrity relies on these exact mathematical proportions rather than rough estimation. This text shows the universal baseline ratio for structural strength, the standard 1:2:4 mix. This translates to 1 part cement, 2 parts sand, and 4 parts gravel. This volumetric diagram illustrates the ratio, showing the significant amount of heavy gravel required compared to the minimal amount of cement binder merging into a single unit. The most sensitive variable in this mixture is water. Water activates the chemical reaction that hardens the cement, but calculating its exact volume is the highest risk factor in the process. This warning details the physical consequences of a water miscalculation. Too much water results in weak concrete, while too little moisture makes the slurry hard to mix and place. Achieving a perfectly batched homogeneous mixture is the only way to ensure the final product is watertight and capable of supporting its intended load. Once the wet mix is homogeneous, it must be transported and placed immediately. If the chemical hardening begins before the concrete is in position, the materials will lock in place prematurely. Gravity presents a hazard during the pour. As this diagram shows, dropping concrete from high elevations causes the heavy gravel to separate from the mix and sink, leaving a thin, weak paste at the top of the formwork. After placement, the next step is compacting. This text defines the process as the mechanical removal of air from the concrete structure. By vibrating the wet slurry, builders use physical agitation to force hidden gas pockets to rise and burst open at the surface. Skipping mechanical compaction leaves air voids inside the slab. These voids create internal weak spots that can lead to fractures when the concrete is placed under pressure. It is a common misconception that concrete simply dries. In reality, it undergoes a chemical reaction called curing, which requires maintaining moisture levels inside the slab as it hardens. This list outlines the methods used to prevent moisture from escaping. Workers will spray the surface with water, cover it with wet sandbags, or use a method called ponding to keep a layer of water on top. Rapid moisture loss stops the chemical reaction before the concrete reaches full strength. This premature evaporation leads directly to surface cracks and a brittle core. Before a project is complete, builders use specific verification tests. These check for 3 things. The slump test measures workability, the cube test checks internal strength, and the compression test confirms the total weight the concrete can hold. Methodical curing and rigorous testing serve as the final fail-safes. They provide the evidence that the concrete has hardened correctly and is safe for use. Despite its final durability, concrete is vulnerable during its creation. If strict protocols are ignored, the structural integrity of the entire project is compromised. This document highlights the 4 primary points of failure: using too much water, poor mixing, a lack of compaction, and failing to cure the slab will result in weak concrete. Professionals use a memory tool to ensure every phase of the operation is completed. This acronym, MBCCCTP, acts as a checklist for the pour. Decoding these letters provides the chronological sequence for a correct operation: mix, batch, compact, cure, control moisture, test, and finally, place. Following this sequence results in a rock-hard foundation. When prepared correctly, it becomes a smooth, level slab ready for subsequent construction. By adhering to these mixing, pouring, and curing standards, builders ensure that the finished concrete meets the necessary requirements for long-lasting structural stability.